So for 19, what you want to do, and this is actually like a good intro problem for us to do. But what we're going to do first is we're going to subtract radical 3 from both sides and divide by 2. Divide by 2, we get cosine x equals negative radical 3 over 2. Okay, so then am I isolated on, is my trig function isolated? Yeah, it is. Okay, so then I ask, for what values of x does cosine of x equal negative radical 3 over 2? Let's start in the first quadrant. Let's not even worry about the negative right now. In the first quadrant, when does cosine equal radical 3 over 2? Either pi over 6 or pi over 3. Jenna? 30 degrees. 30 degrees, correct. So that would be pi over 6. So in the first quadrant, it's pi over 6. But where is cosine negative? In which two quadrants? 3 and which other one? Anna? Is it 4? 2, because it's the x value. Okay, so then in the third, or let's start in the second quadrant. In second quadrant, pi over 6 is the reference angle for what angle? Something over 6. The second quadrant. Hannah? 5 pi over 6. Good. Okay, so it's 1 less than the denominator. And then in the third quadrant, we've got 1 more than the denominator. So what is the angle in the third quadrant? Anna? 7 pi over 6. Am I finished? I got to do what? Hannah? Add the periods. We got to add 2 pi n. I don't think this asked for you. Did it ask for the interval? Caleb's shaking his head no. We got x equals 5 pi over 6 plus 2 pi n and 7 pi over 6 plus 2 pi n. And the reason I rewrite it is this looks to me like it's 5 pi over 6 and that's it, and then 7 pi over 6 plus 2 pi n. Like it looks like these are two separate things, so I like to write it like that just because I think that comma makes it mean something different. Okay. Okay. Then this is number 73. Now, 73 was intentionally difficult, okay? This is actually something we're going to look at today, okay? We did do, what ends up happening is we have to factor this. Now, we did do some factoring in 5.1, not a ton, just a little bit. And that's what we end up having to do is we have to factor this, okay? So we'll come back to this problem at the end of class, all right? So you can go ahead and get your 5 point, well, first, are there any other questions from 674 that you have? Other than like 1973, those two were covered. Any general questions about solving? Okay, so we'll go ahead and start the notes. You can get your 5.5 day 2 notes out. We're gonna skip this problem here. Okay, so we're still finding all the solutions to a trig equation. The only difference is that we now are adding in this factoring. Okay, so you'll see that on your notes it's broken up into two pieces. Step one is factor, and then step two is just from day one. You isolate, ask for what values of blank does blank equal blank, add the period, and then solve for the variable. All right, with factoring, you're going to notice it says replace functions if needed. We kind of introed that last week. All right, I think everybody's there for the notes. All right, there's nothing there. So here's our first problem. Okay, so I have 2 cosine squared x minus cosine x minus 1 equals 0. And we do have an interval. Okay, so right now cosine is not isolated. I also have a cosine squared here. What I'm going to do is I am going to exchange, I'm just gonna make a little exchange here. So I'm gonna say u is equal to cosine of x. And for whatever reason, people use u and v for these a lot. You can use whatever variable you want. Theta, I would not use just because we use it a lot in these problems. And then y can sometimes get confusing because this is equal to y because it's a function. So I don't know, use something different. So I'm going to rewrite. So I have 2, and then if you remember, this is the same thing as cosine of x squared. So what this ends up being is 2u squared minus u minus 1 equals 0. And the reason why we are replacing it with u is just only one reason, is so that it's easier for us to factor. Okay, we didn't change anything about the problem. It just looks a lot easier to factor because we don't have to look at cosine so much. Okay, so we need to find 2 numbers. This is the same thing as PSN, but I do a little, it's PSN, I just say it differently. So we need 2 numbers that add to be something and 2 numbers that multiply to be something. If I do the the negative 1 times the 2, that gives me negative 2. That's what it needs to multiply to be. And then it needs to add to be that middle number of negative 1. Okay, so this would be your P, your S, and then our N are these 2 numbers that make both of those statements true. So if I multiply, what is it, negative 2 times 1, I get negative 2, and negative 2 plus 1 gives me negative 1. We'll factoring a read for you guys. All right, because I have a 2 out front, I need to split the middle. So I'm going to rewrite this as 2u squared minus 2u plus 1u minus 1. That kind of looks like an N. All right, so I took this middle piece and I wrote 2u and 1u to split the middle. Then I'll factor each of these pieces. And I ask, what's the largest thing that divides both 2u squared and 2u? It's going to be 2u. And then I'm left over with, I just say, what's 2u squared divided by 2u? 2 divided by 2 is 1. U squared divided by u is just u. And then 2u divided by 2u is 1. Between 1u and negative 1, the only thing that they have in common is a 1. And again, I'm left with u minus 1. Because these 2 things match up, I'm able to write this as 2u plus 1 times u minus 1. Now, if these 2 things don't match up, then something wasn't factored correctly. And that is all equal to 0. Okay, so we just factored. The factoring step is done. I'll give you a second to get caught up with that. All right, so now what I'm going to do is I'm going to replace this cosine of x back in. So it's going to be 2 cosine x plus 1 equals 0, and cosine x minus 1 equals 0. Okay, and then from here, it really should be pretty straightforward from Friday. We'll obviously go through it together just for review. Okay, so I am just going to focus on the left here first. Subtract 1. I get 2 cosine x equals -1. And then divide by 2. So I'm looking for cosine of x equal to -1/2. Okay, so when is, in the first quadrant, when is cosine equal to 1/2? Jenna? Pi over 3, good. And we already kind of talked about it. It's negative, It's negative in the second and third quadrant. So in the second quadrant, it's our denominator -1, so we get 2 pi over 3. And then in the third quadrant, it's 1 more than the denominator, so 4 pi over 3. All right, and then we add our period of 2 pi n. We'll come back to this when we list our values, okay? All right, then I'm going to solve for cosine on this side. So I have cosine of x equals 1. Now, this is where we get onto those axes. When is cosine of x equal to 1? Or when is x equal to 1 on our unit circle? Jenna?
0 and 2 pi.
0 and 2 pi, very good. All right, and then for our final answer, I am looking for my values between 0 and 2 pi. Are 0 and 2 pi included? No, so these two values are not in the domain. So x is equal to 2 pi over 3 and 4 pi over 3, and that's it. Oh, geez, that's a terrible square. If I add the 2 pi n to either of those values, I am outside of 2 pi. So those are our only two solutions given the domain restriction. Okay, we're taking two things that you already know how to do. I know it's kind of intense, but you'll get to a point where it's fine. Okay, you guys know how to factor. You've been doing that since your freshman year of high school. We learned this on Friday. We're still trying to get comfortable with it, but I think we're doing okay. All right, and we're just trying to put those two things together. So let's look at number 2. Let's factor it together, and then I'm going to leave it for you guys to solve the rest of the way on your own. Okay, so I've got 4 sine squared x minus 1 equals 0. let's replace sine of x with u. Can you guys see that green okay? Emma, you see that green?
No.
Okay. So I have 4u squared minus 1 equals 0. Ooh, hello. We don't have a middle term, but we have 2 squares. So I have 4u squared, that's a square, and negative 1 is also a square. When I'm doing the difference of squares, sometimes it's easier for me to write out what the squares are. So this is 2u quantity squared, and this is 1 quantity squared. So then I can write this as the difference of squares, which is 2u plus 1 times 2u minus 1 equals 0. All right, let's go ahead and split these into 2 pieces. So we'll have 2u plus 1 equals 0 and 2u minus 1 equals 0. And then we'll also go ahead and put our sign back in. So we have 2 sine plus 1 equals 0 and 2 sine, oh, I forgot my x. 2 sine x minus 1 equals 0. All right, I'll give you a second to get all caught up. Take, I don't know, a minute and a half to go ahead and solve this on your own or with the people sitting around you. Okay. All right, take about 30 more seconds of that, guys.
Excuse the interruption. Remy Agundate and Tatiana Folking, would you come to the attendance office, please?
All right, guys, let's come back together here. So as you can see, I already went ahead and solved that. I feel like we can all handle that pretty well. So I have sine of x equals -1/2 and sine of x equals +1/2. Now, you have the option to go ahead and combine those and say plus or minus 1/2 if you want to. But I want to do them separately just so we can really think about our quadrants. Okay, so sine is negative in quadrants, what? 3, and what else? 4, very good. Okay, so in quadrants 3 and 4, sine is negative. Now, in the first quadrant, when is sine equal to 1/2? Hannah? Pi over 6. Okay, so then the reference angle in the third quadrant for pi over 6 is what? Jenna?
7 pi over 6.
7 pi over 6. Good, we've got one more than the denominator. And then what about in the fourth quadrant? Jenna?
11 pi.
11 pi over 6. Just a reminder, it's twice the denominator minus 1 in the fourth quadrant. All right, so those are those ones there. And we'll just put plus 2 pi in. All right, and then sine of x is, we already said, equal to 1/2 at pi over 6, and it's positive in the first and second quadrant. So we've got x equals pi over 6, and then what's the one in the second quadrant? One less than the denominator would be 5 pi over 6, which is 2, or I'm sorry, and then we add the 2 pi in. Now, we are between 0 and 2 pi. I know it seems somewhat redundant to write out this plus 2 pi in. I need you to do that, though, so that I know that you recognize that you are adding the period. But then when we write our final answer, we're obviously going to ignore this, because if we add 2 pi, then we are outside of this domain restriction. So add the 2 pi in, but then for your final answer, we'll just put x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All good? Okay, and then I think this is our last example. Okay, so for this one, let's subtract 3 tangent of x from both sides so we have them equal to 0. Or I'm sorry, so we have both sides equal to 0. Not both sides, one side. Goodness. So I have tangent x sine squared x minus 3 tangent x equals 0. I'm going to call tangent x a and sine x b. All right, so then I have ab squared minus 3a equals 0. Now this right here looks a lot easier to solve than this right here, okay? Or to factor, I should say. All right, I have an a in common, so I'm going to go ahead and factor out that a. So I have a times b minus, what am I doing? B squared minus 3 equals 0. And then I'm going to go ahead and set both parts equal to 0. So I have a equals 0 and b squared minus 3 equals 0. We'll go ahead and replace back. So we have tangent x equals 0 and sine squared x minus, actually, yeah, that's fine. That is fine. With me so far? Any questions up to this point? Okay. So when is tangent of x equal to 0? That would be when x equals 0 and y equals 1. Or negative 1. Hannah? Yep, pi over 2 and pi. And then what's the period of tangent? What? Pi. So we're going to add pi in. Oh, you know what? This should be pi over 2 and 3 pi over 2. Pi is the point of negative 1, 0, so it's undefined there. All right, then for sine squared minus 3 equals 0, let's add 3 to both sides. So I have sine squared x equals 3. And then when I take the square root, I get sine of x equals plus or minus radical 3. All right, this is where we get a little bonkers. So if I wrote this over here so I didn't have to rewrite it again. Okay, if you plug radical 3 into your calculator, you're going to get about 1.732, okay? And that's plus or minus, I should have said. Now, if you remember the domain for sine and for cosine, for that matter, it's between negative 1 and 1 because it keeps going up and down like this forever and ever. Okay, so it keeps going up and down like this. And so it's going between 1 and negative 1. But this 1.732 is like up over here and down over here. Now that stuff in the green is not within the domain. So there's no time where sine of x will ever be equal to positive radical 3 or negative radical 3. So this one right here has no solution. Okay, so this over here, this is no solution. However, we still have, and I'll zoom back in so you guys can get that down. We still have pi over 2 and 3 pi over 2. And then we don't want to add 2 pi because it'll be outside. So our final solution is going to be x equals pi over 2 and 3 pi over 2. That's our final answer. I'll zoom in so you can get all that down. Yes?
At 3 pi over 2, it's negative 1 or 0.
No, it's 0, negative 1 at 3 pi over 2.
I'm not going to turn it down on minus.
Because if we were to draw the graph, then it doesn't go anywhere for x, but it goes -1, so 0, -1. You're good. Happens to the best of us. Wait, or not? Now I'm questioning what our answer is. So if we have, this is pi/2, this is 0, 1, and sine over cosine. So it's actually pi and 2. Pi and, this is wrong. This is supposed to be 0 pi over, sorry, 0 pi and 2 pi. Because this is undefined and this is undefined, so these are the points where tangent's equal to 0. So then only pi is our answer because 0 and 2 pi are not included. So x is equal to pi, and that's it. Does everyone understand that change there? Make sure you change that. Okay, that's because this point is 1, 0, and this is -1, 0. We can't divide by 0, but we do y over x, and that's 0, -1. I may have said it opposite, and that's why we messed that up. Okay, so that is it for those. So just be aware of solutions that might not be possible. So these are not possible solutions. And then these ones, these are not in the domain. So just make sure you're paying attention to the domain restriction. All right, it is 8:55. You know what? Let's save 73. What's your homework tonight? Let's look that up first. Your homework tonight is page 674, 10, 25, 39, 45, and 53. We're gonna save 73 for a warm-up tomorrow morning, okay? So go ahead, get started on the assignment. Let me know if you have any questions.